Okay, I'm recording it. We are going to hit 5.1 today, which I'm hoping will be review for you. It isn't a difficult section. 5.2 is more interesting. It's just one more variable. This section, this entire unit, is just like you have died and gone to heaven in college algebra. This is by far the easiest stuff we will do. Not everything is falling off a log easy, but everything is small little groups, understandable. We don't dive down into anything deeply. I think you're going to, be happy with the way we end here. Okay, the first thing I want to talk about, and I get it that some people may come in later and I'll hit it again, but I want people who are listening to the recording hear this. I had 4 tests turned in yesterday. 2 of them, half of the tests, they dropped out of proctorio within a half an hour of starting their test. If you cannot see, you've got to make sure that you can see your face on your monitor. Your monitor sits here. Your face is sitting there for the most part. Some of you have moved it around a little bit, but for most of you, it's in the upper right-hand corner. You can see proctorio recording you. If at some point you refresh your screen, your computer dies, other circumstances, if at any point you can no longer see yourself, then proctorio is no longer monitoring your test. And that would be like if you were in a classroom taking a test and you gathered up your stuff, went out to your car, finished your test, came back in and tried to hand the test to the teacher. That'd be as absurd as this is. So you have got to make sure that proctorio is filming you. If that little picture goes away, you need to immediately back out, get proctorio back installed, pick up the test again. You'll have the time. It accumulates your time so that, let's say you've used a half an hour of your time while you are busy getting reconnected, that will count against you. But what is that going to be? 3-4 minutes or so. Then when you come back in, you need to show me your work paper where you stopped. I can see where you stopped on your recording. I'll make sure that matches where you stopped on your scratch paper so that you didn't, I'm looking to see, did you write down a whole bunch of problems and go and look them up in this gap? I mean, that is my job, is to protect everybody else from anybody else cheating. So you have got to be certain that you see your face there. This only happened one or two times total in the last 2 tests, but it's happened now twice in 4 tests on this test 3. This cannot happen. If you're warned now, put you on warning here. If this happens to you, I'm not going to accept your test. So I'm telling you in the couple of days beforehand that if you lose this picture of you that's on your monitor, that is proctorio testing you. That is proctorio monitoring your test. If you lose it, proctorio is no longer checking to see what you're doing. And you might as well be in your car. Well, you haven't taken your test yet, Chloe, so you were not. Oh, you mean one of the earlier people from a previous test? I made certain those people knew and took great notes, because if it happens again, what am I going to do? If you keep having the same mistake happen over and over, then that means you're doing something on purpose. So I'm really glad this is the first time we've had a class while a test was in progress. So I get the opportunity to straighten you out, and I'll email everybody also, because I want to be absolutely certain that you understand your picture has to be there. And I know that's just another damn thing you have to be paying attention to that's not like it used to be, and it's not fair. And I'm sorry. I know that that's a problem. It's a pain in the butt for me to have to check on this. The first thing I'm going to do when we get back to regular is go down to the testing center and give them a big old bucket of the best blueberry muffins ever, because I miss them so much. I appreciate them so much. I hate testing online. I hate teaching online. I'm just like you. I hate this. This is not normal. This is not good for human beings, but we are stuck with it for test 3, test 4, and the final. The 2 people that made that mistake, I quizzed them about it. I haven't heard from one of them. The other one told me that he refreshed his screen. So I don't know why that happened. I don't know why he refreshed his screen. I don't understand why it went away, but it did. So don't refresh your screen, you know. I know that. And Ashish turned in his test, so he knew it wasn't him because I wasn't on him about it. He's one of the 4 that turned in his test. But Ashish's stuff took me 6 or 7 minutes to get to me. Ashish, why was it so slow? Why, a lot of you are like at the 6 or 7 minute mark. Why can't you get that in time and get me your scratch in 5 minutes? Do you have any idea? Any thoughts on that?
With me, I have to go to my printer, put my flash drive in, and scan it. But my computer's recently doing it thinks there's a virus on my flash drive, so it scans a lot of stuff and it takes forever. So if I'm late, I'm trying to be faster.
Okay. 6 or 7 minutes is not critical. What I'm trying to protect there is from somebody else having done these problems for you, and then you are copying them over in that space of time. So there isn't enough time in 6 or 7 minutes to copy someone else's work in the right order, you know, because this order would have been, your order is different. So, okay, I can understand that. And I see in the chat, I see all kinds of good reasons for why it would take a little bit longer than 5 minutes. Okay, well, that helps me understand that. Okay, I'm going to save this. Let's see, we got 8 people right now. My phone takes 2 minutes to send the pictures. Yes, and that is another thing. I have had students, I've had students who it's taken 35 minutes. And so what I do is just tell them, send me a screenshot of proof that you sent it out and the electrons just took their time getting to me. And that's settled. That's easy to prove. You know, just show me that you sent it out at 6 o'clock, but it took till 6:30 to get to me, kind of thing. I've done that with several of you in this semester. Okay, so we got 8 of y'all here right now. I will show you this again if more people show up. I'll remind you again at the end of class. Okay, I'll just keep moving. Okay, 5.1. Easy stuff. Let's see what we've got here. Linear systems, that means these are lines in 2 variables. So let me give you, for instance, this system of equations. 8x plus 9y equals 6, and 8x minus 6y equals 32. That's a system. I'm going to use this brace to show the system. 2 equations, 1 equation, 2 equations in the same 2 variables. Both are in x, y. So what we've got here is we're sitting, geez, here we go, try again. Right here, we're sitting at 2 equations. Right here, we're at 1 equation. So 2 equations up here, that's where we are in 2 variables. What our goal is to get down to 1 equation in 1 variable. That's our goal. So what we're going to do, well, we're going to start out by this first problem. They're going to ask you, is 3, -2 the answer? Does 3, -2, is that the ordered pair that is the solution here and the solution there? So all they want you to do is plug it in and see if it works. So let's try that. In the first problem, let's put these variables in here. You know, the first one is x, the second one is y. So we have 8 times 3 plus 9 times -2 equals 6. So we got 24 minus 18 equals 6. That works. So 3, -2 is on this line. Yeah, Chloe?
Sorry, I think I missed the part where you got 3, -2.
Yeah, I wasn't explaining that very well because I thought I was jumping right into the regular problems, and then I glanced over at my notes and recognized that no, I have this first to show you. They'll give you the system and they'll give you a potential answer and ask you, is this the solution for this set of problems? So
Okay.
they'll give you both and you just plug in.
Okay, thank you.
Well, I appreciate it too. I appreciate you straightening that out for probably not just yourself. So they will give you this and ask you, does it work? So let's try this one. We made sure it worked in here. Let's try here. 8 times 3 minus 6 times negative 2 equals 32. Let's see if it works. 24 plus 12 equals 32. No, that equals 34. So it didn't work in this one, didn't work in that one. So is 3 negative 2 a solution for this system? No is the answer there. It worked in the first one, it didn't work in the second one. Let's talk about what it means to work. What it means is this is a line and this is a line. So on some Cartesian coordinate system, the solution is going to be the one place where those two lines cross. So what we're looking at in 5.1 is where do the two lines cross? That's what you're answering each and every time. Where do the two lines cross? Find that one point where those two lines cross. We're not going to graph them to find it out. We're going to use two different methods. If you took our developmental class, you would have found three methods. You would have done graphing, then you would have done the two methods we're going to use today. So let's start with one of those two methods. The first of the two methods is called substitution because we're going to substitute. We're going to start with two equations in two variables. Let me get this down here for you. X minus 2y equals negative 8, and y equals negative 5x plus 15. There's our system. We're going to use substitution for the first four problems here, and then we'll move to the other system. But right now we're using substitution to answer the question, where do the two lines cross? This is a line, it's in xy. This is a line, it's in xy. So we're starting with two equations in two variables. Our goal is to get this to one equation in one variable. So we've got to turn this system into one equation with one variable. Here's how we're going to do that. We are going to look to substitute. We're going to look for y equals everything else in the problem, or x equals everything else in the problem. We're looking for one variable equal to everything else. We don't care which variable, it doesn't matter. In this one, we've got y equals everything else in the problem, so I'm going to box that up, and I'm going to substitute it into the other equation. Everywhere I find a y, I'm going to put this. That's why it's called substitution. See how we're going to do this? This is the substituting block, negative 5x plus 15. I'm going to say x, then a minus sign, then a 2. Oh, there's a y. So in place of y, I'm going to put negative 5x plus 15, and then continue on, equals negative 8. Ta-da! We have one equation right here with just one variable, x's. There are no y's. So we have smushed these two together by substituting one of the equations into the other equation. Okay, let's do what we need to do here to solve this. X plus 10x minus 30 equals negative 8. Combine like terms, that's a 1x and a 10x. And then I'm going to send this 30 to the other side, equals 22. So x equals 2. Okay, now that I have solved this one equation in one variable problem, now I can go back up here to where there are two equations and two variables. I'm going to take this answer that I've got and come over here. Because here's the problem. Remember, where do the two lines cross? So where the two lines cross will be a point, and a point is always an x-coordinate and a y-coordinate. I have the x-coordinate, 2. I need the y-coordinate. I can plug this 2 into either of the two equations. It doesn't matter. But I can promise you, when we do substitution, it's the substituting block that will make it the easiest problem for you. Because look at what you're looking at. You say, okay, I know x, but what is y? And this says y is, I mean, it's handing it to you on a silver platter. Y is -5 times x plus 15, -10 plus 15, 5. So y is 5. There's our answer. That is the answer that answers the question, where do the two lines cross? So 2, 5 will plug into this one. That'd be 2 minus 10 gives you a -8. And then we already showed that this one worked here. 5 equals, plug in the x. So this is the only pair of numbers, the only ordered pair that is a solution for both of those problems. We found where those two lines cross each other. We did it we started with two equations in two variables. We worked our way down to one equation in one variable right here. We substituted in, so we had one equation with just x's. Messed with that a little bit, got an answer, and then we were able to climb back up to the place where there are two equations and two variables and plug in our answer to find the full answer here of 2, 5. Okay, let's look at another one. Let's look at y equals 3/7 x plus 5/7 and y equals 2/5 x plus 1. There's our system. We want to come up with where do the two lines cross. That's what we'll be finding. Notice that they're both in y equals mx plus b form. That's interesting, but not particularly, we're not graphing them, so that's good, that's cool, but whatever. We're in two equations and two variables. There are two equations here. They both have x and y. Okay, we need to find one of them being x equals everything else, or one of them being y equals everything else. And you can see that they're both in y equals everything else. That's cool. Let's just eliminate these two and set these two parts equal to each other. So it's the same as what we were doing before. Let's go ahead and just do it that way. Doesn't matter. Here's my substituting block because I've got y equals everything else. I'm going to substitute that block right there in place of the y in the other equation. So I get 2/5 x plus 1 equals 3/7 x plus 5/7. It's kind of cool when they both are equal to, the same thing. If this equals y and that equals y, these two pieces equal each other. I mean, we did it with a block, whatever, it's the same thing. Okay, this gives us an opportunity before we move further to do something that we've done almost not at all, maybe not once, is to clear fractions. Clearing fractions is a wonderful tool to get rid of denominators. Let's do that on this problem. Let's clear fractions so life is much better. Look at the denominators. You've got a 5. You don't have a denominator here. You've got a 7 and a 7. So the denominators are 5 and 7. If we were doing a fraction where we had to add, like 2/5 and 2/7, you're looking for what the common denominator would be. And the common denominator for 5 and for 7 is 35. You're multiplying the two of them together in this case because they have no common factors. So let's use 35 to multiply every single term, whether he's a fraction or he's not, everybody gets to multiply times the common denominator. So our goal is just to get rid of this nasty fraction mess. You can do this in your head. You're dividing by the denominator. 5 goes into 35 7 times, and then multiply times the numerator. So you're dividing by the denominator. They both start with D. So divide 35 by 5, you get 7, and then multiply times the numerator. So we get 7x. If you don't feel like messing with that, don't mess with that. Multiply this on your calculator. 35 times 2/5, 2 ABC 5. Yeah, it would be. Yeah, thanks. I was getting ahead of myself. Absolutely. I'm pretty sure I said 7 times 2, and then I wrote 7. So yes, it's 14. Thank you. So this will not be 7x, 14x, because 5 goes into 35 7 times, and 7 times 2 is never 7. Not ever is 7 times 2 7. So we'll get 14x there. Thank you. Appreciate that. So you can use your calculator if you would like to. 35 times, and then go 2 ABC 5. And look, we cleared the fraction. That's not a fraction. That's cool. Then you've got 35 times 1. And then we're continuing on. If you want to use your calculator, that's fine. But it's also divide 7 into 35. Divide because it's the denominator. Both begin with D. So we get a 5. And then 5 times 3 will give us 15x. And then a plus sign. And then 7 divides into 35 5 times. And 5 times 5 is 25. Or all the time, feel free to use your calculator. 35 times 5/7, 5 ABC 7 equals, and there you get 25. So if fractions aren't your best thing, no sweat. Don't use fractions. Use your calculator. Don't use your brain, use your calculator, whatever works. Okay, this was 14x, remember? So I'm going to move the 14x over to the right-hand side. So I'm getting 35 equals x plus 25. Move the 25 over, and we get x equals 10. Good, that's half our answer. Where do these two lines cross? They cross at 10. I don't know yet where they cross. It doesn't matter which formula we use. Let's see, let's go back to my model. This model is super simple right now, but when we get a third line added on in 5.2, it'll be more important to you. So I'm starting with this basic model because I know where we're going to go. We're going to add a third layer here. So we started out with 2 equations in 2 variables. We worked our way down to 1 equation in 1 variable when we set them equal to each other. And then we worked our way down to getting an answer. Now that we have one answer, we can go back up to where the 2 equations are and choose. This one is is probably the easiest one, although this was the same structure, y equals, so it doesn't matter. So I'm just going to use my substituting block. 2/5 times x, x is 10, plus 1. Again, feel free to use your calculator, but 5 divides into 10 2 times. 2 times 2 is 4. 4 plus 1 is 5. Or you can multiply the numerators. 20 divided by 5 gives you 4. Those are all good ways. Or you can grab your calculator. All good ways. So 10/5 is the only solution for these two. It's the place on the Cartesian coordinate system, go out 10, up 5, where these two lines will cross each other. That is the answer to where do the two lines cross. Okay, Maria, I think you came in after 8 o'clock. Are you the, somebody came in after, let's see, we had 8, so 2 of y'all came in. Let me grab that list. Yeah, Maria and Catherine. Yeah, you too, yeah. And you're Katie anyway. Kate, let's see, Katie, yeah, okay. Okay, good. So here we go. I had a couple of people take the test yesterday, and half of the people that took the test dropped Proctorio from what they were doing. That little picture of you taking your test on their monitor went away. That means Proctorio no longer is monitoring your test. That can't happen. It cannot happen on test 3, it cannot happen on test 4, and it cannot happen on the final. So you're going to have to pay attention to if you refresh your computer, it's going to go away. If your computer dies and you have to plug your computer in, it's going to go away. And you need to reestablish. And if you have to reestablish, that's fine. You've got plenty of time. But if you have to reestablish, then you have to show me the worksheets that you had so far so that I can see that you didn't do any work when you were in the dark. You have to get your face back up there on your screen and start taking your test again. So I talked a lot about that at the beginning, and I recognize that you probably won't go back and look at the recording because you're here in class. So I want to be sure you know that. If anybody else joins, let's make sure that I know. I'll notice. I'm not. Good, good, good. Okay, let's see. Let's do another one. Let's do another substitution problem. Let's look at 9x equals y minus 4 and 9x minus y equals 5. There's our system. Same thing, we've got two equations and they've got two variables. We want to smush those down into one equation with one variable. We're looking for x equals everything else or y equals everything else. We don't have that. But I do see if I move this -4 over to the other side, then I'll have y equals 9x plus 4. So that's what I'm going to have to do if I'm going to do substitution on this one. That's one of the ways. Another way would be to move this minus y over to this side. Then they'd both be 9x equals. And that would be okay to substitute just like we had in the previous problem. We had both of them y equals problems. If these are both 9x equals problems, then we could set what's over here to each other. But I'm going to go ahead and do it the traditional substitution way. I'm going to move this -4 over there, and I'll get 9x plus 4 equals y. And there's my substituting block. 9x plus 4 will go in and take the place of y in the other equation. I'll put it right in there for y. So let's see, we'll have 9x minus, oh, there's y. So let me put in 9x plus 4 and then continue on, equals 5. So I just, in place of this y, I put in 9x plus 4. Be careful, it's minus all of that substituting block, just the first part. So be sure that you're going to minus both of them. So let's work further here. What we've got here is just wonderful. We've got one equation with just one variable, just x's. So let's continue working on this. 9x minus 9x. If I have 9 x's in my hand and you come along and you grab 9 x's out of my hand, I got nothing. Those cancel out. There's nothing left there. And we're left with -4 equals 5. We don't have x equals 5 or x equals -4. We got no x's. There is no way we're going to be able to fill this out. We don't have a variable equals a number. So we're in weirdo land. What happens in weirdo land is two different things can happen. In this case, when we get a false statement, remember the question is, where do the two lines cross? This says those two lines don't cross. That's what that says, that false right there. We didn't get something normal. Says when it's false, the two lines don't cross. And so where do the two lines cross? The null set. They don't cross each other. Well, you're done with the problem, but it's interesting to think about, so what does that mean if two lines don't cross? But they're in the coordinate system, how could they not cross? Any ideas? Okay, that's fine. The way they don't cross is if they're parallel to each other. So there, they don't cross. Oh, that's a good idea. Yeah, you're using some of your random ideas there, and I think even spelled right. I'm even going to go look. Yay for you. So parallel lines. These will be parallel lines to each other. They're just lines, and nothing fancy is happening here that would require asymptotes. But when you get a false answer, when you get a statement that is false, that tells you that the two lines, well, parabolas will have x squareds on them. We'll have parabolas in a day or so, but not next Monday we will, but not right now. These guys are just going to be lines, and so they will not, if they're not crossing each other, they're parallel. Good. So if you get a false statement, no x equals 2 or x equals 5, if you get something where the x's are gone, you're in weirdo land. And this is one of the things that happens in weirdo land, is that the two lines are parallel. Your answer will not be parallel. Your answer will be the null set, because they're asking you where do they cross, and they don't cross. What is the system? What is the solution to the system? Which means what numbers can you put in here for x and y that will make the statement true? And there is no answer possible because there is no intersection. The two lines don't cross. Let us look at the other thing that can happen in weirdo land. X equals 2y minus 5 and negative 4x plus 8y equals 20. There's our system. Remember, we're looking for x equals everything else in the problem or y equals everything else in the problem. And we've got it right there. X equals 2y minus 5. So we're going to take that substituting block and put it right in there for x. So we're going to have negative 4 times x, which is 2y minus 5. Continue writing the rest of this. There we go. Let's work this out. Negative 8y plus 20 when you distribute. Okay, let's neat this up. And again, it's important for you to notice, if you'll take just a second, I know you're working ahead, some of you, take just a second to notice. We started with two equations in the same two variables. This is an x and y, this is an x and y. They have the same two variables here. When we get over here, we've got one equation with just one variable, y's everywhere, and that's our goal. Okay, let's see, we got negative 8y and a positive 8y. Those cancel out, so we end up with 20 equals 20. Now we're in weirdo land, and the reason we're in weirdo land is because we lost our variable. Once you lose your variable, you can't set up an answer of x and y. So you're in weirdo land, and if the statement is false, you end up with parallel lines. Where do the two lines cross? They don't. That's the null set. But here we ended up with a true statement. What that means is that where these lines cross is every stinking place, not just one place, but every place, which means those two lines are the same exact line, which is a little bit sneaky, a little bit skiffy, but it means they're the same line. Let's look at them. If we move this y over, we'll have x minus 2y equals negative 5. This one is negative 4x plus 8y equals 20. Okay, now they're set up the same, so they won't be as tricky. X, y equals a number. Look what happens. If you multiply x times negative 4, you get negative 4x. If you multiply negative 2y times negative 4, you get positive 8y. If you multiply that guy times negative 4, you get that. So the second line is the same as the first line. It's just everybody's multiplied times negative 4. So these two that we were given are the exact same line. If you recognize it, then you can quit and say, hey, they're the same line. Where do the two lines cross? They cross everywhere. They cross in an infinite number of places. If you don't recognize it, you substitute it in and you get a true statement. You get in weirdo land, no x's, no y's, variables are gone, and you've got a true statement. Remember, the question is, where do the two lines cross? And this says, oh my gosh, yes, they cross all over the place. They are the same line. Now, how that's going to look on my math lab is they're going to say infinite number of solutions, which is lovely of them to tell you that, but that doesn't tell you where they are. So they're also going to be more specific. They're going to say, here's where the answers are. The set of x, y, oops, that's supposed to be parentheses. You're not going to have to write this ever, such that x equals 2y minus 5. That tells us where the points are. Or the set of x, y, such that negative 4x plus 8y equals 20. So that's what your answer is going to look like on my math lab. Infinite number of solutions, yeah, because they're on top of each other. Every point is common with every point of one line. Every point of this line has itself in common with every point in this line. And then if you want to be more specific, here's where those points are. All the xy's that belong to that line, or all the xy's that belong to that line. And this is what your answer will look like when you get a true statement. On my math lab, they'll give you both ideas. There's a whole bunch of points they have in common right there, and then where those points are. Okay, substitution is important to know. We'll be doing it later, but way more fun and way more important to know is, okay, I thought I wanted to be sure that I see what happened. Okay, is the other method. It's called addition in some books. It's called elimination in other books. And it's just fun. We're going to do both. We're going to add to eliminate. That's what we're going to do. So let me show you what we're going to do here. Let's look at 3x minus y equals 7 and 2x plus y equals 3. There's our system. Game is still the same. Where do those two lines cross? We're going to have to find it out, but we're going to use a different method. We're going to use a method that we're going to use a ton here. We're still starting out with two equations, and they're in the same two variables. This one's in xy, this one's in xy. So we're ready to go. We're ready to work them down to one equation in one variable. So let's add these two together. Notice that they're both in xy equals a number, xy equals a number. They have to be set up similarly. They have to be set up in the same fashion. 3x and 2x, that's 5x. Negative y, remember that's a negative 1y, and a positive 1y, they're gone. We just eliminated them. Equals 7 plus 3 is 10. Divide both sides by 5, and you get x equals 2. There we go. Where do these two lines cross? They cross at 2, I don't know yet where. But my little dippy triangle here, now that we have gotten one equation in one variable solved, we're going to go back up to where there are two equations in two variables. So let's take our 2 and go up to one of these. Remember when we had, when we were doing substitution, the substituting block is the easiest place to make that, to figure out what that y is. We don't have a substituting block here. So just figure out which equation looks less likely to bite you in the butt. I'm going to look at the, let's look at the first one, because then I can remind you of a skill that you already have. Let's take the first one. So 3 times 2, just plug in x, plug in place of x, plug in our 2 that we just now know, minus y equals 7, 6 minus y equals 7, minus 6, don't lose that negative, negative y equals 1, so you got to change the sign. There we go, y equals negative 1. So watch out for that. When you've got a negative y, don't lose the negative. You got to divide both sides by negative 1, or just move the negative over, whatever your brain does with it. So there's the answer to where do these two lines cross. This is the only point that works in that equation that also works in that equation. 3 times 2 is 6, minus negative 1, that'll be 6 plus 1 equals 7. And then 2 times 2 is 4, 4 and a -1 is 3. It has to work in both, and you don't have to check it. It will always work in both if you did the work right. Okay, let's look at another one. Let's look at 7x minus 3y equals 5 and 6x plus y equals 15. There's our system. We want to add eliminate here. We add eliminated on this first one, and it was nice and neat. -1y, +1y, they canceled each other out, and we eliminated by adding the equations up. That's not going to happen here. If we were to add these equations up, we're going to get 13x, nobody got eliminated. We're going to get -2y, nobody got eliminated. So this is not going to be as easy as this one, but that's what you're here for, is to learn how to make these things happen. And like I said earlier, in a perfect world, you understand how to do this. This is not a perfect world. I'm sure you've noticed by the time you've reached the age that you are. So we're going to have to do some repair work if you don't know how to do this. Okay, let's look. We can either decide to kill the x's, or we can decide to kill the y's. Now, what I know if I'm going to kill them is they have to have different signs. One is going to have to be positive, and the other is going to have to be negative. I'm going to have to create that if I don't have it. And the coefficient in front, a 1, is going to have to match that coefficient, because a -1 and a +1 will zero out, and that's what we want. Okay. Here we have a +7 and a +6. Think about if we were looking at common denominators, what we'd have to bring both of them up to make them cancel out. We would have to bring this guy and this guy up to, if we had 3/7 plus 4/6, and we were trying to get a common denominator, we'd have to bring them both up to 42s to make them cancel out, to have the same constant, to have the same coefficient. Here it's a little bit easier, because already we have a plus sign and a minus sign. Already we have opposites. That's cool. This is a 3. Let's make this one be a 3, and then we've got opposites and they'll cancel, and we can kill the y's. So I can't just put a 3 right there. I have to multiply the entire equation times that number that's going to make this eliminate. So I'm going to rewrite the first equation, and then I'm going to multiply everybody times 3. 18x, +3y, woohoo, that's going to happen just like I want it to happen. These are opposite numbers, one's negative, one's a positive, same number, equals 45. Now I'm ready to add them together. It didn't come with a nice, neat package here where they were already opposites. I had to make this one be the opposite of that one. I could have attacked the x's to kill them, and we'll do some of that. We'll do some of that where it's a little bit more tricky in a minute. Let's see what we've got here. 25x equals 50, x equals 2. So where do these two lines cross? They cross at x equals 2. And now I've got to go back up. I've got one equation. I found one equation and one variable. I've got to go back up to where the two equations are with the two variables. I've got to go back up to here and plug in my x equals 2. It doesn't matter, whichever one looks easier to you. This one looks infinitely easier to me. And just FYI, you can either of these two equations, or you can use this one that we built up. The numbers will always be bigger on the one we built up, so I'm not sure that's good advice. But either of these two originals are good. Okay, so 6, I'm going to use 6x plus y equals 15. 6 times x is 2 plus y equals 15. So I'm getting y equals 3 there. So 2, 3 is the place where these two lines cross. Okay, isn't this fun? Substitution is just a good time. Sorry, additional elimination is a good time. Let's look at 3x. Oh, that's a good answer. 3 extra points for you, Chloe. 3x minus 5y equals 7, and 11x plus 10y equals 20. There we go. There's our system. Notice we've got two equations. They have the same variables, xy, xy. That's going to be important in 5.2 in a few minutes. Okay, let's see. We want to eliminate here. We want to add these two equations up, and we want somebody to drop out. We want to kill the x's, or we want to kill the y's. If I decide to kill the x's, one is, well, they're both positive, so I'm going to have to multiply, instead of multiplying just by a number, I'd have to multiply by a negative also. So what would we bring up the x's? What would we bring both of them up to in order to kill the x's? Any good ideas there? Okay, that's a good answer. Just like over here, if we were going to kill the x's, we'd have to bring everybody up to 42, to the common denominator. If we were going to do that here, and we're going to in a minute, but the easier one, yeah, 33, bring them both up to 33. We're going to do that in a minute because I want you to see that it works the same whether you pick to kill the x's or pick to kill the y's. But if we decide to kill the y's, that's going to be easier because one is already opposite. They're already one positive and one negative. This guy's a 5, this guy's a 10. We want these two numbers to match. And you're always going to be bringing the numbers up. You're never bring them down to 5. You want to bring them both up to 10. So this is a plus 10y. We can easily make this a minus 10y by multiplying this top equation times 2. Let's move it over here. So we'll have 6x minus 10y equals 14. And let's rewrite the original bottom equation. And there, we're ready to go. We've eliminated the y's. So that makes us happy. We got 17x equals 34. We get x equals 2. Looks like x is always equal to 2 in these problems. It won't always be. But you always will have very nice, neat, low numbers. I think you've got one that's a fraction, maybe not even that. And it's a half. So these are going to be very basic. Okay, now we've gotten down to one equation with one variable. Now let's go back up to where the two equations are to plug in to find the y. So we climb back up the ladder. Doesn't matter which one you grab. I think I'll just grab the first one. So 3 times 2, work that out. Oh, here's our fraction. Minus 6, so we get negative 5y equals 1. Divide both sides by negative 5, and we get negative 1/5. So there we go. 2 comma negative 1/5 is where these two lines cross. That means that we should be able to plug them both into both equations. Be 3 times 2 is 6. Then a negative 1/5 times negative 5 gives us a plus 1. 6 plus 1 equals 7. And then 22, 11 times 2 will give us 22. 10 times negative 1/5, 5 goes into 10 twice with a negative on it. So it would be minus 2 equals 20. So it works on both. Okay, I want to show you what if we had decided instead of killing the y's, let's kill the x's. Let's bring them both up to 33. I'm not going to have room on this piece of paper. Let me go to the next piece of paper. I want you to be able to solve either way and also to know that it doesn't matter which way you go. So we're looking at 3x minus 5y equals 7 and 11x plus 10y equals 20. There's our system. We're trying to figure out where do the two lines cross, and this time we want to kill the x's. So if we're going to kill the x's, we're going to have to bring them both up to the same number. We already talked about that, but we realized it's probably going to be 33 because 3 times 11 is 33. That would be the common denominator for 3 and 11. So we would multiply this one times 11. That'll give us 33x. and we'll multiply this one times 3. That'll give us 33x. But watch out, because 33x and 33x doesn't give you 0. One of these is going to need to be negative, and it does not matter which one. I'm just going to stick the negative on the top. It doesn't matter. So then we've got negative 33x, negative 11 times negative 5 is plus 55y, negative 11 times 7 is negative 77. We're doing the same exact problem, just solving it a different way, because I want you to understand that it doesn't matter which variable you go after. Multiplying times 3, we get 33x, and look, those are gone. That's exactly what we want to have happen. Plus 30y equals 60, so we're getting 85y equals negative 17. Divide both sides by 85. We get y equals negative 17 over 85. Well, wait a second. That isn't what we got over here. We got negative 1/5. No problem. Let your calculator tell you that you didn't make a mistake. So let's put this in here. Get it out of the glare a little bit. There we go. So negative 17, ABC, 85. Just use your ABC key for negative 17, ABC, 85 equals, and there, your calculator will reduce it to negative 1/5. So equals negative 1/5. So where do these two lines cross? They cross at, I don't know what the x is, but I know the y is negative 1/5. I'm going to plug that back into either one of them. 3x minus 5 times negative 1/5 equals 7. You can use your calculator here. That'll give you a plus 1. So we get 3x equals 6. And x is 2, which is the exact same answer that we got before. It has to be. I mean, the truth is the truth, no matter how you go after it. But I wanted you to see that you can mess with these and create either killing x's or, like we did on the previous, killing the y's. It's totally up to you. And we're going to get more practice than just in this one section, because this is the skill we're going to use in 5.2. Okay, let's look at one more little problem here. Got a triangle. We know that that angle is y, that angle is y, that angle is x up there, and then this angle is 2x minus 48. Okay, you got to create your own equations here. We need two equations in two variables, and you can see we've only got x's and y's, so they'll be in two variables. But you need to know a little bit about geometry in order to be successful here. It's not super tricky. I'm hoping that you know that the three angles of a triangle, the three interior angles of a triangle, x, y, and y, when you add them up, you get 180. 90, nah, do that twice, Charles. You get 180. So x and y. Why does the diagram look so perfect? Oh, you mean like they're all 60 degrees there? I just drew it that way. I mean, I could have drawn it much different or slightly like that. You know, I just drew an angle and then cut it off. Okay, so we've got these three. And Charles, let me show you something. If you had a triangle like that, there's 90 right there. So the triangle, all three of them don't equal 90. So those two will equal 90 also in this case. So it'll be 180. So yay for a little bit of geometry, but add a little bit to that. So let's add those three angles, x plus y. That's going to be x plus 2y equals 180. So that's one of the facts that you have to know, is that the interior angles of a triangle equal 180. That word has escaped me. We're not scaling, not right, but where all three are less than 90. I'm just being an old person right now. Thank you. Oh, yay for, yeah, not equal, but acute. Yeah, acute one. See how cute that is? It's just a cute little triangle. X plus 2y equals 180. So the interior angles of an acute triangle equal 180. Actually, it happens on all of them. So the interior angles of any kind of triangle equal 180. So you got to know that. The other thing you have to know is right here, those guys. See how that angle and that angle, that one and that one, are lying on a straight line? Straight line is 180 also. So let's do 2x minus 48 plus y equals 180. So those are our two equations. Those are the two equations that you're going to have to make up. The three interior angles equal 180, and then these two that lie on a straight line equal 180. Let's clean this up a little bit. X plus 2y makes me happy. It's xy equals a number, that's fine. Let's rearrange this one to make ourselves a little happy. 2x plus y, I'm going to send the 48 to the other side. So we get 228 there. There we go. Now we're set. We've got two equations and two variables. We're going to use add eliminate in order to get down to one variable. Okay, let's see. We can kill the x's. If we kill the x's, this one's already a positive 2. That means this guy would need to be a negative 2. I can do that super easy by multiplying him times negative 2. We can do that. Let's keep looking. Here we've got the same situation. If we decide to kill the y's, we're going to have to, this one's already a positive 2. This one will have to become a negative 2. So we would have to multiply this line times negative 2. I think generally it's easy for us to kill the x's because they're the first one in line, and so it's easier for us to see that. So I'm going to go ahead and multiply this line times negative 2. So negative 2x minus 4y equals negative 360. And then rewrite the second line underneath. Bam, killed the x's. We've got a negative 3y. Remember, there's a 1 there. And then that equals, that'll be a 2. That would have been a 4. Now it's a 3 and 1 and a negative. Okay, so we've got negative 3y equals negative 132. Divide by negative 3. So y equals a positive. Good, it's got to be positive. 44, I do believe. 12, yeah. So y equals 44 degrees. That one's 44 degrees right there. Let me put that. This one's 44 degrees. We know this one's 44 degrees. We've got to figure out these others, or maybe they only ask you for the x. I don't know. You figure that out. So now that we have one variable answered, we can go back up to any of the equations. You can also use your brain. You know there's 188 degrees in here. These are taking up 88 of them, so you're left with 96 or some odd. Or you can just plug it in. X plus 2 times 44 equals 180. Minus 88, and we get 96 there. No, that's not right. 92. 180 minus 88, 92. Okay, so we got 92 degrees for this x angle up at the top. I don't think they ask you for the 2x minus 48, but that'd be 180 minus 44. So you'd get 136 there. Okay, so you got to create your own and then decide to kill the x's or the y's. We're done with 5.1. And you might not feel like you're completely ready to do these on your own. No problem. We're going to do the same thing in 5.2. So you'll get more practice. Let's look at 5.2. It is called Linear Systems in 3 variables. Same exact game, except we're going to throw in a z. We're going to have x, y, and z in this. So let's look at how it's going to look. X plus y plus z equals 14. And I'm always going to put a line through my z because otherwise it looks like a 2. X minus 2y minus z equals 13. And 2x minus y minus 2z equals 5. There's our system. It's in 3 dimensions, x, y, z. All of them are, we have 3 equations in 3 variables. On the first one, they're just going to ask you again, like on that previous problem, if that is a solution to this system. So there's the x number, there's the y number, there's the z number, and they're asking you where do all 3 of these cross? Do they cross at that point? So this is just a plug-in exercise. First problem in 5.2 is just a plug-in. There's only going to be one place where these 3 equations cross, and they're asking you, is this it? So let's see, let's plug it in. Into the first one, we'd have 10 plus a negative 7 plus 11. 3 plus 11, good, works there. Let's try this one. X is 10 minus 2 times negative 7 minus 11 equals 13. See, that's 10 plus 14. So 24 minus 11 works there. And then here, 2 times x, 2 times 10, minus a negative 7, minus 2 times z, which is 11, plus 7 minus 22 equals 5. That's 27 minus 22 equals 5. So yes is the answer here. They gave you the problem. They gave you the answer. They wanted you to see if it worked out. You got to do a lot correct. None of it's hard, but you've got to be careful that you don't make a boo-boo, that you don't start planning your weekend in the middle of it and forget what the whole game was. But it's easy to do that. It's easy to plug it in and get an answer. Okay, let's take some problems now. We won't finish this section today. We'll finish it Monday, so you'll have that overlap. You'll have, the time for your brain to think on it and cook on it, and then we'll come back and do the same thing on Monday. That's good. I love that. I love that overlap, especially from Wednesday to Monday. Okay, let's see. Let me start a fresh sheet of paper here. This does take a little bit of paper for sure. None of the math is very difficult. None of the skill is new. It's just putting it, it's Tex-Mex food. It's just take those same ingredients and rearrange them a little bit. Let's look at 8x minus y plus 4z equals 46. X plus 4y minus z equals negative 4. And 4x plus 4y minus 5z equals 7. There is our handy-dandy little system of equations. What we want to do here, what are we doing here? We are starting with, let's see, I want to be sure I got my little guy written right this time. Yeah, okay, inverted triangle. We are starting with 3 equations in 3 variables. You can see that. We've got 3 equations, 1, 2, 3, and they've all got x, y, z, x, y, z, x, y, z, 3 variables. We are going to work our way down to 2 equations in 2 variables first. Then we're going to work our way down to 1 equation in 1 variable. So we are going to work our way down there, down to there, and then we're going to work our way back up there. I'll show you how we're going to do those steps. Starting with 3 equations and 3 variables, now we need to transform these into 2 equations with 2 variables. Because if we can get it down to 2 equations and 2 variables, we can handle that. That's what we were doing here, 2 equations with 2 variables. So we can handle it if we can get it to here. Okay, let's look at what we've got. We're looking for the same sort of thing. We're looking for easy work. I'm looking at x's. We can handle that easily. We can grab, let's say if we grab the first 2 equations, that's an 8x. We could easily make this a minus 8x by multiplying this entire second equation times negative 8. That's not going to be hard. And then we could do the same thing with the 4x. 8, 1, and 4 are easy numbers to work with. I'm seeing these y's that look interesting. We've got a plus and a minus there. We could easily multiply this top equation times 4. We'd have a negative 4y. Here we have a plus 4y. That would be easy to do. And then they drop out. And then for our other pair, our other second equation in 2 variables, we could go after these 2 and just change the sign on one. That'd be pretty simple. Let's work on that. Let's work on killing the y's. I'm looking at the z's and seeing that that would not be very difficult either. I could concentrate on these 2 equations. That's a plus 4. I could easily make this equation a minus 4 by multiplying times 4. And then I could concentrate on these 2 and just make this is a minus 5. I could make that a plus 5. So we've got lots of choices, and it's up to you, whatever looks easiest to your brain. But I'm going to go after killing the y's. So first thing I'm going to do is use those 2. I'm going to grab those 2. You want to note which ones you're using so you don't do that again. You can't grab the same ones again. So let me take these 2 equations, 8x minus y plus 4z equals 46, and the second line. Okay, I'm going to kill the y's here. Kill y's. Okay, let's see, I've got a negative y there and a positive 4y there. Good, the signs are already opposite. Let me multiply this one times 4. That'll give me a minus 4y there. I've got a plus 4y. That's cool. They'll drop out. So let's set this up. 4 times 8 is 32. Then a negative 4y. Then a 16z. And then 4 times 6 is 24. 164 there. Okay. Let's put this one underneath it. Plus 4y. Minus z equals negative 4, and there we go. So we've killed the y's on the first pairing. 33x plus 15z equals 160. Okay, box that sucker up. That's a keeper equation right there. We've got what we wanted to do. We've got an equation in 2 variables. That's just one of them. We need 2 keeper equations. We need to get 2 equations in 2 variables like we had in all the previous problems. But this is one of our keepers, and I don't want to lose him in all this. Okay, so we've got one of them. Let's go back up here and pair another 2 of the equations. I see that I've got a positive 4y here and a positive 4y here. I'm going to go ahead and grab those 2. So I'm going to grab the middle one and the last one. That'll be easy to make them eliminate. Remember, we killed the y's before. You have to be consistent. You have to kill the y's the second time also. You can't go off and kill somebody else the second time around. You have to kill the y's, so you have an x and a z here. We have to kill the y next time, so we still have the same 2 variables left over in our second killing. So let me grab these 2. Okay, there they are. I want to make one of them negative. As it is, when I'm trying to kill the y's, these are both positive. One of them needs to be made negative, and it doesn't matter which one. I'll just make the bottom one negative. So I'm going to multiply the bottom one times negative 1, or just negative. So let's see, we've got x plus 4y minus z equals negative 4. And let's multiply this whole entire row times negative 1. Plus 5z and negative 7. Watch out for that. So we killed the y's. That's good. That's what we want to have happen. We've got negative 3x plus 4z equals negative 11. There we go. That's a keeper equation. So what we have done is we started with 3 equations in 3 variables. We have paired a couple of them. We grabbed these 2, the first 2, we grabbed the last 2. And what we did with each of those pairings was eliminate the same variable. We've eliminated y in this one. That's why we've got an x and a z. We eliminated y in this one. We've got an x and a z. We are ready to go. We are now where we were on 5.1. We have got our two keeper equations. We're at two equations with two variables. Let's now go down to one equation in one variable. So let me move them over here. 33x, I'm just copying this one. And then copying this one. And there we go. Now we are where we were at 5.1. We can handle this. Now we have to decide if we're going to kill the x's or kill the y's. So I'm looking at 33 and 3. Well, the first thing I see is that one is positive and one is negative. I'm not going to have to mess with the negative sign. I've already got them being opposite signs. I want to bring them up to the same number. Did I say x or y? Yeah, thank you. So x and z, yes, got x's and z's. So I can either kill the x's or I can kill the z's. It doesn't matter. I'm looking here and seeing that killing the x's, one's already positive and one's already negative. I've got opposite signs there. That's cool. I don't have to mess with the negative. Now I need to find what number I need to bring them both up to. If these were both denominators and I was trying to find a common denominator, I don't have to multiply them together. I don't have to use 99. That's bigger than I need because 3 goes into 33 evenly. So I've got a positive 33 here. You can't ever go down, Chloe. You can't ever go down. That's not going to work because we can't make this one 11 easily. We need to stick with at least as big as the big guy. So we would make this one match 33 by multiplying in times 11, which is maybe what you were saying anyway. And that's fine, that's great. So this is 33. If I multiply this line times 11, I'll have matching numbers. So you can do that, and that seems pretty easy. That's where we're going to go. But let's also take a minute to look at the z's. If we wanted to kill the z's here, we'd have to bring 15 and 4. They are not related to each other. They don't have a common factor. Nothing goes into 15 that also goes into 4. So in order to get their common number, you'd have to multiply them. 15 times 4 is 60. So we'd have to bring them both up to 60. We'd bring that one up to 60 by multiplying times 4. And we'd bring this one up to 60 by multiplying times 15. We'd also have to remember the negative business because these are both positive. So by far, it's going to be easier to just multiply this one times 11, and then we will kill the x's. So let's go over here. We got 33x. I'm just going to copy the top line. Z equals 160. And then multiply everybody times 11. Ooh, there we go. That's going to be nice to cancel out. Plus 44z equals negative 121. Gone. So we're working our way down to one equation in one variable. Let's see, this will give us 59z equals positive 59. Notice how nice and neat that is. Z equals 1. Okay, way back up here, x, y, z. We've got z as 1. Let's put a 1 right there. So we have got one equation in one variable. We are done. We are at the bottom. Now we have to work our way back up, green arrows. We've got to work our way back up. We've got to go back up to where there are two equations and two variables. We can't go climbing back up here. We don't have enough information to come up here. That'll be later. But right now with our one piece of information, we're going to go over here to where there were two equations and two variables and choose one to solve for x. Let's grab the second one. So negative 3x plus 4 times z, we now know what z is, and work this out. The math is easy for you. Plus 4. So x is 5. Sure.
For the 33x plus 15z equals 160 and the minus 33x, plus 44z. Isn't 160 minus 121 39?
I
Or
hope not. Yeah, it is. So something went wrong because this one will work out. Let me grab my notes. This is why I do notes, because otherwise, let's see, plus 44 equals 180. Did I copy this down wrong somewhere at some point? Let's see, 180. 33x. Where did I get that? I got that right there. 4 times 46. Yeah, plus 20. There's the problem. 46 times 4 is 184. So here's the boo-boo way up here. Thank you, Chloe. Appreciate it. 184 right there. 4 times 46. Did that public math. Got 24. Put the 4 down. Put a 2 there. That's 160 plus 2. I just didn't add it in. So this becomes a 180 right there. So that's our keeper equation. This is a 180 right there. And then, so this is a 180 minus 121. Poof, it's finally right. So that was just a boo-boo up there. Sorry about that. That's all is good now. Thank you. Yeah, and that's a really good lesson, though. If you're working this problem, I mean, I knew this was going to come out okay. I didn't know it was going to be a z equals 1, but I knew it was going to be good. So I just sort of crossed my eyes and knew that'd be close to 59. But if you get 39, like it should have been, then something went wrong, because you are not going to have z equals 39 over 59 as an answer. You're going to have nice, fat, round, whole numbers. You're not going to have messy, disgusting, scary fractions. So if you did do something like what I did, and you put a 39 there, because that is what that was originally, that tells you that you did something wrong, which is what I knew when Chloe said, "Ooh, look at that, that's not right." Somewhere up here it went wrong, because I knew this worked out nicely. So trust that you're not going to have weird stuff here. You're not going to have weird fractions. They'll work out pretty for you. Okay, so we had the z equals 1. We had one equation and one variable. We had to climb back up to where 2 equations and 2 variables are happening. This is where they're happening. This is where, either one of our keeper equations. If you can't find this, that's fine. Use the keeper ones that you've boxed. Either one of them. I grabbed this bottom one, found x equals 5, so I've got 2 equations done. Now I'm ready with my 2 pieces of information. I know z, I know x, and I can go up to 3 equations in 3 variables. Grab any one of these and plug in the 2 pieces of information I do know. I'm just going to grab the top one. It's 8x minus y plus 4z equals 46. So 8 times 5, we don't know y, plus 4 times 1, 40. 46. Looky there, we've got a 40 and a 4 on the same side of the equal sign. So we've got 44 minus y equals 46. Move the 44 over. We get negative y equals 2. Nobody cares what negative y is. So y equals negative 2. And there's our last answer. So way up here, the answer is 5, negative 2, comma 1. 5, comma, negative 2, comma 1. The x, the y, and the z for 3 systems and 3 equations. Okay, we did 1, and we'll do 4 more on Wednesday. So you've got, if you don't want to bother with this, don't bother with it. Bother with 5.1 though. First, let's see. Let's get it all in the right order. First thing you have to worry about is your test. You got test 3 to take. Most of you still have to take that. Let me remind you again about what I told you at the beginning of class. You have to make sure that you can see your face in the monitor. If you cannot see your face in the monitor, then you are not recording yourself. Proctorio is not on, and I'm not going to grade your test. You're not going to get a grade for it. You have to make sure that you are connected. It's the only way that this can be valid for your test grade and fair for everyone else. So get that done first. And then before Monday, try to hit 5.1. I wouldn't bother with 5.2. We have just barely touched on it. And my guess is it's pretty rough right now for you. It won't be. When we get done with 5.2 on Monday, you'll understand how to do 5.2. You know, one time does not make you an expert. So finish your test by Friday night, and then see if you can't get 5.1 done by Monday when we meet again. Okay, let me stop recording.